Today we're going to be solving systems of equations by either the graphing method or the substitution method. These are the two methods that you did last year in Math 8, so this is a review. So first, let's just go through the vocab and remind ourselves. So a system of linear equations is just a set of linear equations that are considered together, where each represents a straight line in a graph. And it can be two or more lines. However, we in algebra will just be living with two lines. And then the solution is just the point, or if it were more than two lines, it would be the set of points. But in this case, it's the point where all the lines in the system intersect. And then there are three different types of systems that we can get. So we can get one solution. This is where the lines intersect at a single point, and that is called a consistent because it does intersect like it's supposed to, and independent because they intersect and then they just go their own way. So consistent, independent, and that's going to look like this one right here. Then we can get a no solution, and that means they are parallel. They never intersect, so they are inconsistent. They don't do what they're supposed to. That would be this one. Or we can have infinitely many solutions, and this is where the two lines are always intersecting because they end up being one on top of the other. They're identical lines. And so these are called consistent and they're dependent because they're stuck together like glue. So those are the three types that we can get. Okay, so then let's go ahead and try graphing. So I am going to do this first one in red. So I am going to put a dot at -1. I'm going to do a slope of 2, up 2 over 1, up 2 over 1, up 2 over 1, down 2 over 1, down 2 over 1. And on the first line, you've got to get every single point in that line because you have no idea which is the magical point where they're going to intersect. We're going to call that line A. Okay, so then I'm going to do my other one in blue. I'm going to call it line B. So I'm going to go to +2, and then I'm going to do a slope of -1, down 1, right 1. And then as soon as I intersect that second line, I can draw, and this is line B. And so the solution is where the two intersect, and it intersects at 1, 1. So these lines are consistent. They did what they're supposed to. And they are independent. And one way that we can kind of figure this out, every time we have a one solution, the two lines are going to have different slopes. However, if it's no solution, they will have the same slope. And then if this one is parallel, they'll have different y-intercepts. And then infinitely many solutions, they're the same line. So they're going to have the same slope. And they're going to have the same y-intercept. So that's also another way that you can kind of make sure that what you think should happen is actually what does happen. All right, so one way to do this is by graphing, but graphing isn't always the most practical way. For example, this one was really easy to find the solution because they intersected at whole numbers, or even if they intersected integers. But if they were to intersect at rationals, like fractions or decimals, graphing method is not going to be the most useful method. Same thing where graphing method, if the numbers in the equation are extremely large, graphing method is not the best. What if the two lines don't intersect until the point 2050? Well, you're not going to want to graph that. So there has to be other ways to find the solution to a system. And one of those is the substitution method, which you also did in Math 8. And the substitution method has 4 steps to it. So step 1 is just to find an equation where one of the variables is already isolated. And if there's not one, then you would have to do it. So step 1 was really, really easy. C is already by itself, so C equals 3D. Okay, step 2 is to take the other equation, and we're going to write it down, C plus D equals 20. But then I am going to substitute in, that's where the name came from, the 3D, because it tells me C equals 3D. So then I'm going to put plus D equals 20. And now I'm just going to solve. So 4D equals 20, divide by 4, D equals 5. Okay, so now you're going to go back to step 1. C equals 3D. C equals 3 times, and now you're going to substitute in the 5. So C equals 15. And then when you write your final answer, you write it as an ordered pair, and it's alphabetical. So C will go first, and then D will come second, just like X, Y. Oops, I wrote D instead of writing D's value, which was D's value, which was 5. Okay, so this, because there is one solution, we would say it's consistent and it's independent. All right, let's try the next one. So for step 1, it's not already done for us. So if it's not already done for us, we want to try to find the equation that if I were to isolate the variable, I would not have to deal with fractions, because we have proven time and time again that when something involves a fraction, we make silly computation mistakes. So I'm going to go ahead and go with this one. If I can't end up rewriting one of the equations and avoiding fractions, then the substitution method is probably not going to be the most time efficient. So on this one, you can isolate either letter. You can isolate X or Y. So I'll go ahead and isolate X. So X equals 9 minus Y. Again, it does not matter which one you isolate. So now you're going to take your other equation, 2X plus 3Y equals 20. So 2 times plus 3y equals 20. And I am going to substitute in the 9 minus y. So now I have 18 minus 2y plus 3y equals 20. So y is going to equal 20 minus 18, which is 2. Okay, now I'm going to come back to the first equation. X plus y equals 9, x plus, and I'm going to substitute in what I just found y to be, which was 2. So, oops, go back to orange. X equals 9 minus 2 is 7. So then my final answer is going to be 7, 2. So again, this is consistent and it's independent because we had one solution. All right, let's try one more. And again, we just talked about this. In step 1, we are trying to avoid fractions. That's our goal. So step 1 on this one has already been done for us, which is very, very nice. So I'm going to say y equals 2x plus 31. And then I've got 2x minus y equals 18. 2x minus equals 18. And I am going to substitute in 2x plus 31. So I have 2x minus 2x minus 31 equals 18. So negative 31 equals 18. And as soon as this happens right here, step 3 is not used, and we can go directly to our final answer, And in this case, it is no solution. That is a false statement. Negative 31 cannot equal 18. So we know that it means two lines are parallel, so it is inconsistent. And that is the end of today's notes.